All right, guys, so today in class we were talking about the breadboard, and we were talking about how these columns are connected all the way down, and then we were talking about how these rows, A through E, are connected, and then F through J are connected, and we mentioned how E is not connected to F. So you should have a breadboard that looks exactly like this if you're a fully online student at home. So what I want to do is just kind of show you guys real quickly here how I can manipulate power around the breadboard. So in your kit, you should have a battery, and you should have a battery snap, obviously. So if we just connect this onto here, red is positive and the black is negative. So I'm going to take the red wire and I can plug it into the positive of the breadboard here. Now you'll notice that the red is labeled positive, the blue is labeled negative, but I want to tell you that the breadboards aren't intelligent. They don't necessarily know. So you can put, your positive wires in a negative strip. It's just there for organizational kind of purposes. So if I plug this in here, I now have power running all the way down here. If I took a jumper wire, I could take a jumper wire from the bottom here to here, and I now have power coming all the way through here, through this wire, and through here. If I took another jumper wire, or maybe I take this jumper wire here, and I go over to this side, I now have power coming all the way down through here, through this wire, and all the way up over here. I could take this same jumper wire and put it here. And now I have power running through here, down here, through the wire, and through this row. If I move it to the other side of the groove, now I have it running through this row. So you can see how you can kind of manipulate it around. I could also take a jumper wire and go anywhere in this same row, any one of these 4 holes, put it here, and come back over to here. And now I have power running all the way up here and down here. So like I said, it's really important to understand how the breadboard works. Otherwise, you won't be able to make a correct circuit. So the first thing I'm going to do, I just grabbed an LED. I grabbed a little push button switch here, and I grabbed a 220 ohm resistor. And I'm just going to make a little circuit similar to the light switch in your bedroom or when you walk in a room. So I have power coming all the way down here, as we have seen already. I'm going to run a jumper wire from here to, just one of these rows right here. So I'm just going to bring power down here and into here. The first thing I want, just like in the wall in your bedroom, is the switch. So I'm going to put the switch in any one of these 4 remaining holes in that same row. I have to take the other end of this switch now and put it somewhere else. The only place I can't put it is in the same row. If I put it in the same row, I've just shorted out the switch. Electricity is lazy. It's like a middle schooler. So it's not going to go up through the switch. It's just going to stay down here and never make a pass. So you have to force it to go through. So I have to go somewhere else. So I'm just going to go up here. Again, it doesn't matter where I go, just as long as it's some other spot. Now I want to put in my light. My light's an LED in this case, and I want you guys to take a look at this LED because this is important for the rest of the course. You'll notice that there's a long leg on the LED and there's a short leg on the LED. LEDs have polarity. If they go in backwards, they won't work. So the long leg is positive, the short leg is negative. If you're a short person, you don't know what's in the cabinet above the refrigerator. But if you're fairly tall, you can reach that, and that's positive. So tall, positive, short, negative. So I'm coming from the positive side of my battery right here. So I'm in the positive side of my circuit right now. So I want to hook up the positive long leg of my LED. So I'm going to connect that to my switch. And again, I have to take the negative leg now and go somewhere else. I cannot go in the same row that I'm already in. That would short out and not work. So I'm going to go from this row to a different row, like that, right there. Now, LEDs can only handle a certain amount of voltage, and we'll get into later on what colors can handle what voltage and all that. But right now, all you need to know is a 9-volt battery is far too much for an LED. This will burn it out instantly. So I'm going to take a 220 ohm resistor and just kind of knock down the voltage of the battery a little bit. So I'm going to put the 220 in where I left off with my LED, and I'm going to put the resistor again somewhere else. You guys have heard this before now a few times, but if I put it in the same row, the resistor does nothing. There's no resistance because it just bypasses it. So we have to force it to go through there. So I got to put this somewhere else. Again, doesn't matter where, just anywhere in the breadboard. And so now if we take a look at what we got, we've got power coming in here, down here, going through the jumper wire, through the switch, through the LED, through this 220, and that's going to go back to the negative of the battery. So I plug this in, and you can see absolutely nothing happened. But that's because I have a push button switch here. So if I push the button, this light hopefully lights up. And it did not. I love doing demos when they don't work. Oh, there we go. Something was just a little bit loose. There we go. So you can see I just moved the resistor a little bit and it started working. So it probably wasn't making a connection down in the board. So I hold that in, it's good. I let go, it's not. So hopefully that gives you a little bit of an idea of how to kind of manipulate power and sort of work on a breadboard. Tomorrow we're gonna kick off our first set of circuits. And so hopefully this will be a good jumping point for you there with that. All right, good luck.